On a crisp Saturday afternoon in October, Ohio State hosted Maryland for a game at Ohio Stadium. It was 3rd and 10 for the Buckeyes, just minutes into the first quarter, when the ref suddenly blew the whistle. A small drone had started hovering above the shoe and its 100,000-plus fans. Eventually, the drone moved on, the game quickly resumed, and the Buckeyes won by 20. But that wasn't the end of the story. Police found the man piloting the drone, and he now faces multiple charges for flying it without a license and in a place where it isn't allowed. Drones are still pretty new, and most people don't know the rules around their use. Truth is, these devices are only getting more common, and they're being used for all sorts of interesting reasons. In today's episode, we're going to talk all about drones. What's so exciting about this technology, and what sorts of problems could it solve? I'm Amanda DeJong, and you're listening to Now at Ohio State. We talk with researchers, innovators, and bold thinkers who look at our world, see what the real challenges are, and create the solutions that people need now. Drones have become popular for hobbyists, and they've been used by the military for quite a while, but that's just scratching the surface of what they can do. Here at Ohio State, we have a whole lab dedicated to drones. It was founded by Matthew McCrank, a research scientist at Ohio State's Aerospace Research Center and an assistant professor of mechanical and aerospace engineering. He talks with R. Ross Bischoff about the work his lab is doing, the future of drones, and why they're not delivering our pizzas just yet.
All right, Matt, thank you so much for being with us today. So we visited your lab as a team, and it was like walking into an industrial art shop meets a high-tech facility. What's it like for you to show up to that every day and know that this is your lab?
Well, hey, thank you. Glad to be here. And I'm going to steal that description of our lab for starters. I think that's great. And I'm glad that came through because, our lab is really focused on taking fundamental ideas and principles in aerospace and actually getting them to fly, right? Taking that sort of next logical step of getting it off of the drawing boards and actually getting it into the air.
How would you define a drone or an unmanned aerial vehicle? What would be your definition for that?
You're going to get phone calls on this one. So this is a bit of it's evolved over time, and I think to anybody who's listening to this, when they think drone, they probably have an image in their head, and I will tell you that image that may be in their head is different than the one that would have been in their head 5 to 10 years ago, right? So this has been an evolution of not only the term but also how people have perceived what these vehicles are and what they did. So generally, 5 to 10 years ago, when you said drone, the typical thoughts were maybe slightly more militaristic, right? So thinking something that the Army Air Force was involved in. And then in that same sort of time window is when the civilian applications of drones and the sort of hobby drones came into our lexicon, right? And we started to be able to buy them off of Amazon and out of the stores, right? And it was something that everybody can sort of engage with. When people started buying them out of the stores, I think their relationship to what a drone was changed very quickly. And it went from this idea that it was this, military asset to something that you bought, almost a toy out of a catalog, right? And I would say the reality is really the technology between the two are very similar, right? But the perception is very different, right? And so, we've kind of walked this tightrope of defining them sort of based on their mission set, right? So the word drone now encapsulates all of those different capabilities from the very, very small things you can buy now at gas stations. I just saw the other day, which is crazy to me as a researcher in this field, all the way up to the what we call Group 5, which are going to be something that's actually the same size as a 737.
And your students, they learn how to create every piece of a drone, correct? What is the student experience like in your lab?
Yes, they love me and hate me for it all at the same time. Yeah, so I've long advocated that one of the expectations of being in our lab is that you're not a user, you're a creator of these technologies, right? So almost nothing of what we have is something that we bought off the shelf, and it's usually not just because I'm being difficult or hard on them, but it's because to really push the boundaries, they really need to understand the nuts and bolts of what's going on under the hood, right? And very little of what you can buy off the shelf allows you to do that and push buttons in the right way that sort of builds knowledge. I mean, even as something as simple as for a lot of my students that come in that don't have a great or a lot of background in electronics, how to hook up an LED, right? Get it to turn on, get it to blink. Let's start there, right? And then take that knowledge and evolve it to the point that they're, competent and actually, doing inertial measurements and all these other sort of things that actually make these vehicles fly, right?
What I think is really interesting about your lab is you sort of, at least from my perspective, there's sort of two paths you go down. And one is creating really cool drones, but then the other is creating a safe airspace for the future of these drones.
Sure. So we've talked a little bit about the drones themselves, and I think that's a very tangible part of the project. But there's this larger question that gets asked, and when you mentioned, what is a drone? And I mentioned that people, started buying them out of the stores and going out and flying them. I think very quickly they realized there are actual rules about where you can fly, what you should be doing, as what your responsibility is as a pilot are. And very quickly, what became evident is that there really weren't a lot of rules on the regulatory side. This would come from a body like the FAA to really govern how best do we utilize this new technology and capability, and what are going to be the rules about where you can fly, how you can fly, and those sorts of things. And so what this set up was what we call a center of excellence, which is a consortium of universities that are essentially selected to help the FAA answer those questions, right? Where can you fly? What can you fly? What are the capabilities, et cetera, et cetera? And so one of those early questions that got asked was, if you are flying a drone over a large group of people and think, people want to do aerial shots of a stadium or a football game, OSU game, et cetera, what ought to be the capabilities of that drone? How large can it be, right? And what are the safety requirements for if it falls out of the sky? What sort of kinetic energy can it have when it impacts, right? What are the limits of what we can do? And so a lot of this was initially answered by modeling, right? So we set up computer models to try to simulate, what happens to a drone that's falling out of the sky. And this evolved into, well, okay, prove it, right? And so we built, I used my apparent, my siege weapons 101 knowledge to build a large catapult system to actually catapult full-scale drones into crash test dummies. To really look at sort of what are the actual mechanics of that impact scenario, how do the drones actually maneuver and behave, what happens after the impact, et cetera, et cetera. But one of the things that came out of that is that crash test dummies really are not designed to take top-down head impacts like what you might see from a drone. So again, the project evolved as we learned more, and the question came, can we do this on a real cadaver? Is there anyone in this consortium of universities who has that capability? And again, I'll speak praises to Ohio State. I think one of the most fascinating aspects of this large university is that there are just an enormous amount of researchers that do a lot of really cool things here. And lo and behold, we have one of the preeminent cadaver testing facilities in the country. And so a quick phone call made fast friends with some of the researchers associated with that group. We had a proposal in within a couple of weeks to the FAA, and we actually did that work. And so we partnered with them. They brought over cadavers to our facility, and we were able to conduct the tests necessary, again, to inform now what those rules are for how and where you can fly vehicles in public. So that's, I think, a really great exemplar of how that research, it evolves based on new knowledge and new understanding as we go through the process, but has a direct tie-in to public policy and can help shape where and what we can do and how we can utilize the national airspace. So I think it's a really neat kind of a closed-loop project there.
And on the drone side itself, you have some fascinating stuff happening. You've set world records. You're talking about going to Mars. I mean, let's, first of all, like just kind of,
Sure.
we'll take a step back. But I mean, you have a great
pretty
definition.
broad portfolio there.
But you have a great definition of the trajectory of your lab. Start there.
Sure. So the way that I always describe our lab is fundamental to flight test. And so it's really taking those fundamental concepts in aerospace engineering that are going to allow us to improve performance, safety, reliability of these vehicles and really push the envelope in terms of what they can do, and actually maturing them and developing the testing procedures and all of the science that's required to actually get them to flight, right? And prove it via flight test.
So why would we want a drone on Mars?
So drones are a natural expansion of capability over what we've seen with the ground-based rovers. Ground-based rovers that have been up there, we've sent, NASA has sent several up there over the years, generally move very slowly and have sort of a limited range over which they can do sampling or execute their missions. Drones, by virtue of flying, can cover a much larger area much more quickly and are kind of a natural partner to that ground-based mission to allow more comprehensive sort of mission planning and telling that ground rover where to go and where may be interesting to actually take a look at. Right, so there's a natural synergy between those two capabilities.
And you have students in your lab actually working on components of a drone that one day may actually partner with NASA and get up there, right?
Correct. So we are working on the blade designs right now for what these rotor blades are actually going to look like that, again, allow a vehicle to operate at 100,000 foot altitude. So these blades look very different than what a normal propeller or normal rotor blade actually looks like. So rather than a nice, smooth, curved surface, they're faceted, right? So there are a lot of flat plates that kind of stick together. And you can think about it, this is not a direct equivalency, but they actually share more in common with things like dragonfly wings and insect wings than they do a 747 wing.
Down here on Earth, I think a lot of us thought by now we'd have drones delivering our pizzas and our shoes and flying all over, and we haven't seen that.
I'm still waiting for it. Yes.
You're still waiting for it. I'm still waiting for it. So talk about why we haven't seen that yet.
That's a great question. And when I sort of originally got involved in this field, that was the promise, and that was the thing that was going to happen in the next year, and that was close to 10 years ago, right? And we're still not there yet. And what I think happened is I think a little bit of that optimism ran into reality. And the challenge with that is that you're not the only one out there. You're not the only thing out there, right? As our research lab, one of the major programs that we have is actually in partnership with the state of Ohio to develop what are called uncrewed traffic management systems, UTM systems. And it is intended to be sort of that air traffic control for the low altitude airspace where we see these drones maneuvering, right? So how do you keep these vehicles away from each other and away from everybody else that's in the airspace and orchestrate it in such a way that you don't sort of unduly impose delays on these vehicles?
All right, Matt, thank you so much. All this work is fascinating. Thank you so much for doing this today.
Yeah, thank you. I really appreciated the opportunity to chat with you, and I really am excited about this space, and I think over the next couple of years, we'll start to see more of this in the airspace, and that's a real exciting thing.
There's so much cutting-edge research around drones, and it only makes sense that students are at the forefront of this work. Enter Aditya Ramaswamy and Jack Murray. They graduated from Ohio State just this year, and in their time on campus, they founded Parawave, a company that is developing drones to help first responders in emergencies. Aditya and Jack speak with Ross about their company's vision, how they got started, and how Ohio State's entrepreneurial community was key to their success.
Aditya Ramaswamy, Jack Murray, Team Parawave, thanks for joining us for this.
Thank you for having us.
Thank you for having us. Yeah.
I remember I believe it was April 2022, I attended the final pitch session of the first cohort of the President's Buckeye Accelerator. And one of the projects that just fascinated me was what became the Parawave team, this idea that drones can save lives. Jack, explain to us what exactly this project is.
Yeah. Imagine that you're at home enjoying a peaceful evening with your family, and suddenly a fire erupts and you're thrown into a panic as you try to make sure that your families, your loved ones, everyone at your home is safe. A house fire occurs every 90 seconds every single year, and a fire doubles in size every 30 seconds as well, so there's really no time to waste. And for us, that's where Parawave comes in. Parawave is a company engineering drone technology for first responders in the autonomous realm, so that way they can get a bird's eye view of an emergency, so that way they can save time and focus on what matters most, saving lives.
I honestly didn't know drones were capable of this. Can you explain what that first product will do for first responders?
So we've been hard at work over the past year. For context, we just graduated from Ohio State with our bachelor's in aerospace engineering. Throughout that year, thanks to the President's Buckeye Accelerator program, where we received really invaluable mentorship, as well as $50,000 in funding, we were able to kick off a project where we developed the first version of our drone. And while out in the market working with first responders on the ground in the local Franklin County and wider Ohio areas, a lot of really big key needs that they emphasized were custom tailoring solutions for them, and specifically applications for inspection. So things like, we want to have a camera on board. We want to be able to use it for search and rescue operations, especially, as well as fire operations. We need a camera that can get really good resolution, can zoom in really well without losing resolution, and can have a great thermal sensor on board too.
And with our first product, it'll be manually piloted. And then in the upcoming years, we are looking to develop autonomously flying drones, where the drone is able to figure out by itself what is the best flight path that I need to take, being able to process the images and videos that it sees, and then pick out critical information. So that's the larger vision for Pairwave, to engineer autonomous drone solutions for the emergency response space.
And something that we've seen resonate really well with the public safety space has been the ability to operate autonomously while also identifying key information. So as an emergency evolves over time, how can we pull the most important analytics that are going to matter the most to first response teams, so that way they can save time in analysis, so that way they can also be best informed as they work on the ground.
So we're talking about a fire erupts. These drones can fly out immediately and help them assess the situation so that when they arrive, they have a really good understanding of, okay, who's in the house, where are they? Talk about what these firefighters are really like, dial down in on what they can get from this.
Yeah. There was actually a really impactful story that we had first heard from a battalion chief out of Columbus Division of Fire when we had first started this venture about a year ago. And it was about the paint plant explosion that had happened. I believe it was, and Aditya, correct me if I'm wrong here, I think it was about 2 or 3 years ago from now.
Yep.
During that paint plant explosion, they had to have, if I remember correctly, hazmat on scene, as well as fire. They were searching through, after an explosion, the rubble of a building for 3 missing individuals that they were not able to get out of the scene. They were able to save a good number of people, but they were still missing 3. They were searching throughout the span of the evening and the night. They were able to find 2 individuals. However, the third, unfortunately, was found deceased later that next morning. When we were speaking with that battalion chief, he had brought up that if they had had a drone on scene that night with a thermal camera, it would have greatly aided in the search and rescue process to identify where those people could have been in rubble. So when you're seeing a thermal image, you can see potentially through objects, depending on the temperature differential. And that's something that really greatly aids in that search and rescue for missing persons, especially in those kinds of emergencies. And especially in ones where when hazmat is involved, it's so hard to safely ensure that first responders can be on the ground working to save lives, or on the ground even just searching for people. So for us, that was one of the first things that we had heard in the first response space about drones from people just in the Franklin County area. And that really, really fired us up to be like, hey, we need to take our technology and help out as much as we can here, so that way we can help save lives.
And it's not just firefighters, right? I probably should say that there's a whole... Tell me, everyone, that this could benefit Aditya.
Yeah, it's the emergency response space requires coordination between multiple different types of agencies. It's fire departments, police departments, Homeland Security, FBI. It is a very versatile space. When we had competed in President's Buckeye Accelerator, we had the name Firefight Arrow. We both had a ton of passion in the drone space. We said, all right, we want to do something meaningful with our passion for drone technology. And then we solidified on, let's do something for the emergency response space. Let's take our passion for drone technology and see if is there a way that we can support first responders. So we said, maybe fire departments probably could utilize drones with thermal imaging. And then we started meeting with a few departments to get their input. And we competed under the name Firefight Arrow in President's Buckeye Accelerator. But as more and more conversations happen, we received a lot of feedback of the emergency response space. There is a lot of cross collaboration between agencies. So then that got us thinking, well, let's rebrand the name Pairwave to engineer drone technology for the entire emergency response space. And that was a huge learning curve for us too, just of developing an understanding of what is the emergency response space, because neither Jack or I have any first responder experience. And the departments that we worked with in Franklin County have been absolutely phenomenal and so supportive. And really, the people that we've spoken with, the feedback that they've given, the support, the positive reaction that they've had of, hey, there's these 2 students that are looking to start a business to engineer drone technology for us. Just the amount of positivity that we received has been invaluable, and we're so grateful. Pairwave is also proud to be located in Columbus, Ohio, officially, and is looking to be in Ohio for the foreseeable future. We're Buckeye strong, and we're excited to be doing what we're doing.
What is really interesting to me, and I think it shows how great the President's Buckeye Accelerator is it really helped you guys hone in on an idea, because where you guys are now wasn't the first idea like a laser light show with drones or something. I mean, probably at the time it seemed like an awesome idea, and to see how far you've come. Talk about that first idea.
The idea that we had at the time was drone light shows, which are very cool. A lot of people have seen them at the Olympics. They're really mesmerizing. And we got into the accelerator under that idea, got in, evaluated it for about a couple weeks, sat down with it, really considered it. And we're like, you know what? There's a mix of things here for why we think that we should pivot. The biggest one for us being we want to take our technology and apply it to something that we're passionate about. We're extremely grateful to the President's Buckeye Accelerator program for helping guide us through that decision-making process. Because for us, we had never built a business before. We had never had to handle a pivot in a business idea either. And I think it was it was a mix of our passion as well as the encouragement from our mentors in the accelerator through Boost Camp that really guided us through that as effectively as possible. And I'm glad that we did, because we saw some really good traction immediately after, consistently, and continued on through and ended up becoming part of the first cohort.
Jack, what advice would you give for a future student or maybe a younger current student at Ohio State?
Yeah, I think the biggest thing that I can say is don't underestimate what you can learn and try new things. When I had started at Ohio State, I originally came in a completely different major from where I started, pharmacy, and realized that while it was a really great field, it wasn't for me. Moved over to aerospace, tried something new in a realm that I was passionate about to learn more things about it. And since then it's stuck. Went into the drone space and again, took the leap of faith, and since then it's stuck. Took a leap of faith into the realm of entrepreneurship, and again, it's stuck. And I think the biggest thing that I've learned throughout all of this has been that there is so many different routes for opportunity that you might not traditionally see if you go down the beaten path. So don't be afraid to go off every once in a while and try something new.
What about you, Aditya?
Yeah, for me, I would encourage students to step into the unknown, step outside your comfort zone. And similar to Jack, I started off pre-med my first year of college and then found my way into aerospace engineering. I'd also encourage students to let passion drive their decisions. Like once they found something that they're really passionate about, hone in on that passion. Let that be your center in terms of your driving force and opportunities that you explore, or maybe opportunities that you say no to really hone in on that. And the last thing I'd say is be fearless in paving your own path. That's something that I learned, and I would say my time at Ohio State has been transformational, and I'm grateful to be a Buckeye and a proud Buckeye for life.
Well, Jack and Aditya, thank you so much for doing this. This has been incredible to talk to you both.
Thank you so much for having us.
New technologies always take time to catch on, and sometimes they end up being used for purposes nobody thought of. It's safe to say that, one way or another, drones will now be a part of our future. Maybe one day we'll get used to looking up and seeing them there, hovering wherever we are. We're not quite there yet, but Buckeyes like Matthew McCrink, Aditya Ramaswamy, and Jack Murray are pushing the boundaries of this technology in fascinating ways. Now at Ohio State is produced by the Ohio State University's Office of Marketing and Communications. For more information, visit us at go.osu.edu/now. I'm your host, Amanda DeJong. Thanks for listening.